You may or may not remember that we were looking at this because we had gotten this in from I don't know, I think it was a drone that we had ordered. It came in. This was part of the stuff that came in. And we put a 7.4 volt battery. We plugged it in and smoke came out. I don't know what we did wrong, if that was a cause, because this takes a 3-cell, which is an 11.1 battery, I guess. And so that it shouldn't have been an issue. But there are 3 prongs on this plug, and there was only... No, there was 3 prongs on it because it was a standard setup. So it was the balance plug should go into there. I think this takes a cell, and what I mean is it takes a pack by default, probably 18650 batteries. I don't know, but you should be able to plug a LiPo in it, and we could not. Oh, we did. Plugged in just fine, but it didn't act just fine when we plugged it in. So let's see. Shouldn't be this complicated to get screws out. Just ain't want to let go. 1, 2, 3. And there's 2. Well, maybe that come out. Okay. So we have 1, 2, 3, 4, 5, 6 screws. 1, 2, 3, 4, 5, 6. Okay, so we got all the screws out. That was a little more complicated than it should have been. And hopefully that is a module. Yeah, it is. So that plugs in right there. Let's grab my phone. And I'm going to take a picture of how that USB plug is plugging in. Okay, so we got that. So now we can unplug that. And then we got this, which I'm just going to go ahead and take a picture of it just because I can. I don't think you can hurt yourself by taking too many pictures of something as you take it apart for the first time. Now, here we have, I don't know, it just seems kind of straightforward. So that's been pulled off of that side. Smarty Parts 9X Programmer. As always, special thanks to the real heroes of the 9X movement, the firmware gurus. So I don't know what this is. I mean, I don't know if that's some kind of add-on board that they tied in or if it's actually part of the original. What's actually set up with these things, or I don't know. But we'll get back to that. So here is where I plugged it in, right there. So let's just get this out of the way. And we'll pull this board here, because this is tying in. This is apparently the power supply, and it piggybacks these switches here. So I'm not entirely sure why this did what it did, but I know 11, unless the polarity was reversed or something somehow. But I mean, it was a Lipo battery that I plugged in, so it shouldn't have been that big of a difference. Nothing out of the ordinary. We're going to, again, as usual, take pictures. I don't think they're so much needed, but we may include these in the video. Ooh, I don't know if those come out. Nope, those are not. At first, it looks like plugs, but it's not. So those are just kind of hard schmackarooned in there. There's a diode right there. You can see here how there's some discoloration and the prongs are kind of bent a little, and I think that happened because of the intense heat or short circuit condition that it experienced. When I plugged that Lipo in. So these two outside ones look like they're tied into the ground right here, and in the center is coming over here to here. And it actually comes to here. Which that is going out to this plug here. And I don't know where else from there. So let me get my meter real quick. And we'll do a couple of little tests and see what we get. I'm going to start continuity. So they're not shorted with the center pin. They are connected like I thought. So this is grounding to both sides. So we got 3 pins that appear to be grounding. So so the ground was tied in out here. I don't know. Let's go to 0.56. And I don't get anything the other way, so it's doing its pure diodeness. 0.5. See if there's any marks on it that tells me anything. Okay, I'm gonna have to probably take pictures of that from my phone and zoom in to get the numbers and everything off of that. But I don't see any pure D badness. This I assume would be the charge port, and this is the data port to program and stuff like that. Looks like this may have been set up for batteries to be stacked in here at one point. I'm really confused. I mean, I'm very reluctant to put voltage on this thing again. Because I'm concerned with it smoking. So I'm wondering if this is some kind of a specialized LiPo battery pack that plugs into, that plugs into this, and you can't plug, well, the plug's over here, and you can't plug just a regular LiPo into that, although it's 3 connectors. That's not sufficient for a that's what it is. Okay, so that's what it is. Because you got a ground on the outside and a ground on each side of this, and the center is your positive. And so this doesn't, you can't plug a balanced lead into that, because the balanced lead is going to have negative, and then it's going to have each one of a positive from each one of your cells. And so essentially what I did was I connected ground to ground, and then I took and had this third positive, or the second positive over here, plugged into a ground going looping back, and that's why it did the short. And so this is some kind of specialized connector to allow you to plug in a battery pack that is going to be 3 leads on it, but still be 11 volts. I don't know how that works, but the battery packs that I've seen online are 11 volts. So that you can't even plug a 2-cell into this right here, because like I said, each side of this plug right here is both negative. So I'm probably going to clip my power supply into this off of these leads right here. Yeah, off of these leads right here, because I should be able to supply. And I'm going to start with, do some more research, but then start with lower voltage and build myself back up. So I'm looking at this antenna section right here, and I don't think it is an antenna, because there's no connections here. I mean, there's nothing. So I think this is something that was just shoved in there to fill a hole, to be honest with you. Or potentially this at one point did go to some part of the module and they rebuilt it, possibly using this for the transmitter and that other part. Kind of, I'm wondering about that, the TX9X or 9X or whatever. Hair club for men. I apologize. I don't know who y'all are. If you're watching a video, don't hurt me. But I'm gonna research that to find out what that is. And so I think this has been modded, which is cool. I do that. I can't. I just almost can't have anything without modding it. I just want to make it my own. I want to do my own stuff with it. So with that said, I'm going to probably take a break, go eat dinner with my wife and kids, and come back to this for later on. So FSTH9 back. So let me just because I can. Telemetry EZ. MOSFETs. 1, 2, 3, 4, 5 MOSFETs in there. Node. Don't know if this right here is aftermarket, because this, could potentially be. This didn't seem professional the way it was in there. Just slipped into that slot and it was loose. So I'm kind of wondering if this hasn't been highly modified. That's kind of cool if it has. AK. I don't know. I'm going to do some research, and when I come back, then we're going to talk more about this. And I might just see about putting some par on this mummer jimmer. I don't know if I have a, let's see, got that. Does it fit? It fits. So when I come back, we'll probably have some wires going from that to my bench power supply. And I will drop the amps way down. We'll hook this all up and see if we can get some lights to come on, screen to far up, because I don't think it's smoked. I really don't. I think I think I may have unplugged it fast enough. Okay, so we might let some more smoke out, and we might not. So I've got this tied into my bench power supply, and my research tells me that this takes 8 AA batteries, which is 12 volts, and it says that's a total of 12 volts. And so that was my assumption at the 3-cell LiPo, which would be 11.1 volts, or technically maybe a little higher than that, right at 12 volts there on its own. And so I have my power supply set at 12 volts, and I am setting the amperage limit at 0.5 amps, milliamps. So we're going to see where we're at. Let's see something. There we go. I'm sorry. So 0.5 amp, which would be 500 milliamps, which is what we're setting the amperage at. I probably should try 250 right off, but I'm figuring we should be fine at 500. So I'm going to turn the power supply on. It's active. I am drawing 0.012 watts, 0.001 amp, and 11.995 volts. So we're looking good there. So let's turn the switch on. And we don't appear to be getting anything with the switch turned on. So we may have ended up with some damage when we plugged it up before. Okay, so let's cut that. Well, it's 0.01 watts now. Still no amperage draw. So let's power it back down, turn that channel off, and we're going to disconnect these leads. So, and what I'm doing is basically and I just pulled all that up in Atom. Make sure I may have had that lifted up and didn't realize it. So let's try it again real quick, just for a double check. And this I may be wrong. This may not be a charging port, or it may just be charging and it doesn't allow enough to supply voltage. So let's turn it back on. We're at 0.01 watts, 0.001 amp, and there's absolutely no difference. So now let's turn the power supply off. Let me disconnect this. We're going to talk about this board in just a minute. So let's look and see if there is a simple way, which technically I guess it is, because this center would be positive. And these two here connected would be negative. But see, I'm not going to be able to connect to that and close The positive goes through the diode. Let's do some more little checks here. We can go back to diode test. And again, I mean, I don't know if this diode's any good or the correct 0.5. And so technically, I mean, I could have blown that thing out because not actually in the circuit. So it's not pinging anything of that nature. So I'm trying to think of the best way to try to put voltage in through here. See, this is my problem because this through these not pogo connectors, but spring connectors to this board, and that's the ground. That's connecting the ground plane to the remainder of the circuit. Let's see. So how is this connected into the circuit? Let's see that. See, that's not part of it. So I'm not getting voltage there because this is the ground side. Not getting voltage there. So I don't really know exactly what that is, but it's not supplying voltage through here like I would assume. Those connectors are just aggravating. See, I just don't see what I can work out here. I can maybe come up with some kind of master plan. I believe if I get voltage going into the right place, it's gonna fire up or blow up. It could do that too. So let's try to move these around. Tell you what, I better put a screw, at least one, in that board because it's floating pretty doggone good. Okay. Now maybe that'll help that. Oh yeah, much better, much better. So let's see if we can get this connected to the middle. These are so aggravating. I mean, well, not usually, but just the ones that I have, because I have the cheap Chinese stuff. Then again, I don't know, maybe they all like that. Just bend this stuff all around till I mean, I already believe I need to replace this connector with something, especially that I will be able to connect. Let me try this. Spin it up. You know what? If I can pull that piece of plastic off there, like I said, the whole daggum thing needs to be replaced. So, you know, with something that'll take a balance lead. Okay, so now that now I don't recommend that you guys try any of this, and I should have said that at the beginning. But then again, I assume a lot of common sense in today's world. And I don't mean that negative against anyone, because I'm the world's worst about not displaying a whole lot of common sense sometimes. So, but I say that because a lot of people don't, like me, they don't think about the consequences, and they end up with a uh-oh or a ooh-wee. You don't want an ooh-wee, because an ooh-wee is ugly. Okay, so now I can clip these leads onto those terminals. Oh, I would assume a good pair of these would not pop out so far that they come out of the little track there that keeps them keyed correctly. And I'm just hooking up one lead, or one negative, put it that way, on it. Let's pull the throttle all the way down, off, and we got 0 watts, 0 amps. And I turn it on, and she fires up. And 0.075 EL switch warning throttle. I guess that's throttle. Alarms disabled. And then there we go. Flame wheel. So this is already pre-configured for, I believe this was set up on the 4G LTE drone. I believe it was. And so now I know in 11.6 volts. So we're good on our voltage. Actually, it's 11.992 volts is what it is. So we're good there. That's all well and good. It's like it needs to be. So I mean, I proved my point. It's still functional. It's good. It works. There's no problems. Turn the power supply off. So I need a 12-volt power supply to tie into this. And I'm going to go ahead and turn the power supply off. And it wasn't even pulling 0.1 amp. It was 0.075 amps is what it was pulling, and it was 0.9 something watts is what my power supply showed. So I know now that I didn't destroy anything. No, I bought this separate. I bought this completely separate. I didn't find this with a drone. So yeah, so this apparently was set up for a flame wheel drone. So this right here, like I thought, is a daughter board, specifically designed for this FlySky controller to upgrade it and to allow it to be easy to upgrade the firmware on this. So this right here is a TH9X, but has been with this effectively upgraded to, let's see, let me go back into my notes here, an ER9X. So this is effectively an ER9X now, and not a TH9X because of this board right here. The Smarty Pi 9X programmer allows for a solderless upgrade to the FlySky TH9X, also known as the Tearedown 9X, to an ER9X firmware by physically installing the board inside the transmitter and connecting it to the computer via USB. The upgrade enables features like LCD backlight, which I don't know if this has that. I don't know, but it was lit, but I don't know. Anyway, support and allows you to load custom firmware, backup configurations, and download model templates. The installation involves opening the transmitter, connecting the programmer board, routing cables from the battery compartment, and then using software on a computer to flash the new firmware. The FlySky TH9X requires power from 8 1.5 volt AA batteries, and so that's where I found the information on the voltage that I needed to set up in here. So this board upgrades this controller to a higher grade controller, allowing you to put custom firmware on it. And so I think that's pretty cool. I believe that, and I've got to double check all of this stuff, but I believe this right here is strictly, I guess, for charging a battery, a Lipo battery, and not powering the unit. So, because this was allowing 0.5 amps, or was it I don't remember. It was showing 0.5. This is where I don't know a lot about electronics, is what the values and stuff should be versus what they are. And I'd have to get the numbers off this diode and research it to find out. But my meter was showing 0.5 as the reading off of that right there. And so I need to take here and add something to allow for a battery connection, a proper battery connection. And this is simply to let you know what I've figured out. This is a ground negative. This is a ground negative, and the center pin is positive. So I just connected to this one and this one right here, and it powered up. or I could connect to this one as negative and the center as positive. But these two outside ones are connected. I could just basically rig up or build an adapter that will plug into here, leaving a dongle in the battery compartment that I could plug a LiPo battery into. I'll have to be careful there because I need to make sure that I end up with the correct results. Yeah. I may just need to get the battery holder and just use it as is with the regular battery holder. Because I could install, I'd have to leave one of these outside pins out. And that's why I put a 2-cell LiPo in here, which was only 7.4 volts, and it's not enough to carry it. It would have to be 4 connectors here. And I would need, because I believe, so on your balance lead, you have your ground. And so if it's a 4-cell, you have 5 leads, because one's a ground and the other 4 are each one of the individual cells. And so the device can use those cells independent, plugged into that balance lead, theoretically could use independent cells or all cells combined. And in series or I guess parallel, either way. So I would have to probably come off of this, just tie my grounds together, come off of this as a positive, and then I would have to loop all of my positives on my LiPo battery output to get the 12 volts. Yeah, thinking about it, I just need to go with the regular battery adapter that goes in here, and so that's what I'll do. I think I seen one on eBay. I could probably 3D print one and build one, but that's too much sugar for a dime. It's easier just to go through here and get one and put it in here. And what I'll probably just do is 3D print the back compartment to snap on here. And go that route. So while I'm running my mouth, let me go ahead and start pulling this board so I can put it back together. I got pretty much what I wanted to know. It's not trash. I didn't destroy it. It is powering and booting up, which is awesome. We're going to take and go ahead and slide this back on there. It's not really in bad shape. It did heat up. And I mean, it was close, but luckily I yanked it back out of there before it caused any real damage. Straighten these pins back up because I'd been around to connect. That pin right there is pretty soft because it did take a jolt from the heat. And so I don't know, I may end up just going ahead and replacing this whole connector. I'm sure I've got some of these connectors around somewhere. But we'll cross that bridge when we come to it. And I'll have to do a little bit more exploring to figure out for sure what that is, because it will not support the power requirements in this transmitter. It will only support a small voltage, which leads me to believe, like I said, because it is tied into the circuit, it's just not tied into this part right here, which is the power supply portion of the circuit. So turn the bench supply off, and so we're going to do some more. And again, like I said, I don't like the way this right here is actually tied into the system. Just kind of hanging out there. I think that's all well and good, but I think it's correct when I come back in here and put some hot glue on that baby to lock her into place all the time. So let's get these screws back in. Oops. Okay. My computer went to sleep. That's okay. I don't need it to be awake. And I don't know how old one of these transmitters are, to be honest with you. That screw's almost stripped. So let's get this plugged in. Okay, so there we go. And I was getting some kind of error, and I don't know if it was maybe when that switch was up. I was getting switch errors. So usually your switches have to be in a default set, and it could be a calibration. I think it was the throttle right there, but there could be a calibration issue. Maybe this trim is moved, adjusted, or something. I don't know. Could be a number of things. But I'm not too much worried about that. So the buttons did respond. I didn't check all of them. I could have started flipping these switches and to make sure that I get a response from them. But I'm not really worried about that at the moment. That'll come later when I go into some details with it. And we'll go from there. So you'll see this again. And I may just call this part 1. And then that means I'll tag on to it with a part 2. So I appreciate you being here. I thank you. I look forward to seeing you again. And I'll see you next time. Your time is very important to me, and I thank you for spending it here with me. Thanks, and God bless.